Hello, everyone. So we are now on the last topic for the solids of revolution, which is the cylindrical shell method. So this is the last method, for solving uh, solids, solving the volume of a certain problem. Okay, so actually, some of our examples in part one and part two videos in can be solved by the cylindrical shell method. So in your exam, I may be or may not be requiring you to demonstrate what kind of method you are going to use. So just prepare, and I hope that you'll be expert by solving some of the methods so that you can answer or you can ace your exams. In cylindrical shell method, you will have the formula volume is equal to 2 pi the integral of shell radius times shell height. Okay, so sorry about that. I forgot the limits from A to B. So here are two problems, two basic examples. Use the shell method to find the volume generated by revolving the region bounded by y is equal to 1 over x. Then y is equal to 0 as x is equal to 1 to 4 about the y-axis. So y is equal to 1 over x is a graph which would look like this. It will never touch the y and x-axis. So parang ganito po siya. Okay, so same goes here. Basta na siya, no? Like that. Okay, so again, the limit is from 1 to 4 sa x. So let's say this is 1 and this is 4. So itong region lang po dito yung we're going to find the volume. Okay, so this is the axis of rotation, that's the y-axis. Okay, and then we're going to use or to create a strip. No? Creating a strip will look like this. So if we are going to have a vertical strip, that is because our axis of rotation is y-axis. No? So the axis of rotation is parallel to our radius, is parallel to the radius. Therefore, the strip that we're going to make is the radius. This one will be our radius, the shell radius. Okay, why? Let's see why. Because if you're going to rotate in y-axis, okay, I will be apologizing on my drawing. Okay, di siya ma-visualize. I hope ma-visualize. So if you're going to rotate in the y-axis, so it will look like a cylinder, no? As you can see, para siyang cylinder. And like that. Okay. So again, our radius is parallel to our axis of rotation, meaning this is our shell radius. And our shell height will be this one. That's our shell height. Okay. So since this is the region bounded, no? Region bounded. So we can draw more strips here. So again, rotate, rotate. Then you can form a volume. Now you can form a three-dimensional shape. Then we can find the volume of the problem. So 2 pi, then our shell radius is r, right? So what is r? the radius from this point to this point. So that is 1 over x. That is our radius, right? Now, what will be our shell height? So our shell height is just equal to x. Then, we forgot, no, that's dy or dx, no, whatever. So this is obviously dx. Then, what is our limit? So obviously, since we use dx, so our limit is from 1 to 4. Therefore, that's 2 pi, cancel. That would be the integral of dx is x from 1 to 4. Therefore, that's 2 pi 4 minus 1. That's 2 pi times 3 is equal to 6 pi cubic units. This is our answer. Okay, for problem number 2, use the shell method to find the volume generated by the region bounded by y is equal to x and y is equal to x squared. So this one, we have two functions. Kanina kasi, we have a curve and y is equal to 0, then x equals 1 to 4. Now, here we have a parabola and a line. So this is a parabola, which is y is equal to x squared. And we also have a line. So this will be our line. Ay, yan. Tama na. Okay. So this is our y is equal to x squared, and this is y is equal to x. Now we are going to rotate again about y-axis. So again, since our radius is parallel to our axis of rotation, so this is our radius, cy. No? So this is our radius, which is ang y. Okay? Then our height is this one, x. Okay, so what is our radius here? Take note, this is from this point to this point. What is this? This is y, right? And from this point to this point, that is another y. So that's another function. So this right here minus this one would be the radius here. Therefore, what is this? This is y, which is equal to x. So let's write that in formula form. So that is x minus this one, which is another function, that's x squared. Okay, so again, kani siya minus kani is the radius here inside the curve, the two functions. So that is our radius. And then, our height, which is the x. That's our shell height, sa kataso ng height. Then, dx. Since the strip is a vertical, then that's dx. Again, parallel, then that's our radius. Okay, now what is our limit? So we are going to find the points of intersection dito. Okay, so obviously that's from 0 to what? Now to find that one, you have to equate both sides. So that's x is equal to x squared. So you can do x squared minus x is equal to 0. Then you can get here two values of x, which is x is equal to 1 and x is equal to 0. So therefore, our limits of integration is from 0 to 1. So that's volume is equal to 2 pi Then from 0 to 1, this is x squared minus x cubed dx. Okay, we are now going to integrate both. So that's 2 pi times x cubed over 3 minus x4 over 4 dx. Then, dx, sorry. That's from 0 to 1. Next would be v is equal to 2 pi, then 1/3 minus 1/4, okay, minus 0. So 0 cubed over 3 minus 0, 4 over 4, that's 0. So what is 1/3 minus 1/4? That's 1 over 12. So volume is equal to 2 pi times 1 over 12. So that's pi over 6 cubic units. This is your final answer. All right, so guys, you can read books, watch videos, more videos, and solve problems to practice your analytical thinking skills in the solids of revolution. Okay, because a lot of techniques or a lot of different techniques are being taught. My technique is different from the others, so you can learn also from them. No, do not depend on my lectures lang. So you have to find ways for you to improve yourselves as well. So thank you for watching this video. I hope you have learned something. You can ask questions to me. Just send me a message. Thank you so much and have a good day. Bye bye.